Welcome students to Lesson 1 of Unit 11. The learning targets in this lesson are to understand Boyle's law and be able to work problems using his equation, and also to understand Charles's law and be able to use his equation when working problems. First of all, Boyle's law. Robert Boyle investigated gases while holding the amount and temperature constant, and he discovered that pressure and volume are inversely related. They are inversely proportional, which means as one goes up, the other goes down. So the equation for this is P1V1 equals P2V2. P and V1 are representing the original conditions, and P2 and V2 are representing the changed pressures and volumes. If you've ever used a bicycle pump, you've experienced Boyle's law. As you push down on the handle of the pump, you would be decreasing the volume and increasing the pressure, and that causes the air to go through the hose and into your tire and pump it up. This diagram we see right here, the pressure is 1 atmosphere, the volume is 1 liter, and the temperature is 298. Notice the temperature is remaining constant. The only thing we're changing here is the pressure. In the middle diagram, the pressure is doubled, and look at the volume. It is 1/2 what it used to be. So pressure is getting larger, twice as much. Volume is half of what it was. And then in the third picture, we see that we had quadrupled the pressure, and we have volume of 1/4 what it originally was. So this helps you get a sense of that inverse relationship between pressure and volume. Before we begin to look at Boyle's problems, be sure you have in your notes standard temperature and pressure. It's referred to as STP. Standard pressure is 1 atmosphere, which is equal to 760 millimeters of mercury, which is equal to 101.3 kilopascals. And standard temperature is 0 degrees Celsius, but all gas law problems must be worked with your temperature in Kelvin. So if we're given Celsius, we have to add 273 to convert to Kelvin. Remember, you've done a conversion worksheet before we started this unit, so it's assumed that all this information is in your notes and understood, and you know these equivalencies for what's known as standard pressure. Okay, the best way to approach these problems is to read the information and make a table of all the values that you're given. We see 1.00 liters of a gas at standard temperature and pressure is compressed to 473 milliliters. So what's changing is the volume. It becomes even less than half of what it was. So if the pressure is the volume is decreasing, we expect the pressure to be increasing. That inverse relationship between pressure and volume is what Boyle's law is all about. So what's the new pressure? The unknown is the new pressure. So let's make a table and identify what these measurements represent. Okay, 1 liter is the original volume. Okay, so V1 equals 1.00 liters. The pressure, original pressure, it says standard temperature and pressure, so P1 would have to have been 1.00. I'm just going to use atmospheres. You're going to come out with the same answer no matter which unit you use for your pressure, but it's easy to use atmospheres because it's 1. And then we are changing the volume. So V2 is 473 mils, but we need to have our labels in agreement. So I'm going to move my decimal point 3 places to the left and convert these milliliters to liters. So that's 0.473 liters. And the question is, what is the new pressure? So I'm solving for P2. Well, Boyle's equation is P1V1 equals P2V2. All you have to do, now that you have identified the measurements given in the problem, is plug them into the equation. So P1, 1.00 atmospheres, times V1, 1.00 liters, equals P2, the variable, times the new volume of 0.4773 liters. Okay, so we're going to multiply 1 times 1, and we're going to divide that by 0.473. So P2 equals 1 atmosphere times 1 liter divided by 0.473 liters. So the liters are going to cancel, and we're going to have a label of atmospheres. So run it through your calculator, and 1 divided by 0.473 is 2.11 atmospheres. So this is our final answer. Always think when you're finished with your problems, is this reasonable? If our volume is less than half, the pressure should be more than double what it was. And that's exactly what we found the pressure to be. 2.11, a little more than double the original pressure. Charles's law. Charles found that if you hold the amount and the pressure of a gas constant, the relationship between temperature and volume will be direct. They're directly proportional, which means that if temperature goes up, then volume goes up, and vice versa. Here's a graph of volume versus temperature, and you see there's a positive slope. This is always the way a graph of a direct relationship will look, and you probably recall that from math as well. So, the equation for Charles's law is V1 over T1 equals V2 over T2, where the ones are the original conditions and the twos are the changed condition. Okay, so let's try this Charles' laws problem. 395 milliliters, which we know that's a volume, so I'm going to record that as V1. Of methane gas at 25 degrees Celsius. So there's my T1. However, we have to be sure we always use Kelvin. So 273 plus 25 gives me a temperature of 298 Kelvin. And it's heated to 100 degrees Kelvin. So T2, we're changing the temperature here. T2 would be 273 plus 100, which is 373 Kelvin. What is the new volume? So V2 is what we're looking for. Charles' equation, V1, you got to always remember V is O on top of T. V1 over T1 equals V2 over T2. So plug into the equation 395 milliliters over T1 of 298 Kelvin. Please, please be very sure you always convert your Celsius to Kelvin. All gas law problems, temperatures must be in Kelvin or you will not get a correct answer. V2 is our question mark. It's our variable we're solving for. And T2 is 373. In class, the best way to work this problem is simply cross multiply. 395 times 373 divided by 298 to solve for the new volume. So V2 equals 494. Oops, I didn't put my label here. This is Kelvin. So Kelvins are canceling. You're multiplying and dividing. The volume is in milliliters. However, if we look back at this original temperature of 25 degrees Celsius, we probably should round this off to 2 sig digs. So we're going to call it 490 milliliters as our final answer. And finally, let's decide whether this is a reasonable answer. What's happened here is we've increased our temperature. If the temperature increases, we expect our volume to increase as well. It started out at 395. It's now 490. So yes, this is a reasonable answer. Okay, so Boyle's and Charles's law. Tomorrow in class, I'll be showing you some really exciting demonstrations involving these laws, and we'll have a worksheet to practice the problems.